most of you are not yet at the brick wall where you're like, I can't go any further, or I've got an answer, but it's clearly not right. But most of you are, if you're not at the brick wall, you're heading towards it. Okay, so I'm going to stop you now, and I'm going to walk you through how this works. Okay, so here's our setup. Maybe I should get the question. A police car approaches an intersection at 80 feet a second. Okay, so at this point, by the way, if you have your police car going down or going right or whatever, I hope you sense that it doesn't matter which directions it's going in. So long as everything is relative to each other, the same as mine or yours, the maths will end up being the same. Okay. So anyway, police car's going 80 feet a second. Okay. Crazy imperial measurements. And a car, when it is 200 feet from the intersection, so this distance here, a car crosses the intersection traveling at a right angle from the police car at the rate of 60 feet a second. If the policeman directs his beam of light, which, I don't even know what that means really, but he's going to be pointing at the car, that's the important thing. At the second car, how fast is the light beam turning 2 seconds later, assuming both cars continue at their original rate? So at this point, you're like, what's going on, okay? This is the moment where it starts, and then 2 seconds pass, right? So if this is, your police car here, and this is your second car at the intersection, right? 2 seconds pass, so I assume the police car gets closer to the intersection, so he might be, say, here, right? And then the other car is still driving in the same direction it was, so maybe it's moved up here, okay? And the actual quantity, how fast is this thing turning, right, refers to the angle between these 2 points. So that angle there, theta. Okay? Now, so far, most of you, it seems to me, have said, look, I've got P and I've got C, and they're both, their positions are changing, right? So I'm going to call this X, and I know what dx on dt is. Dx on dt is the rate of the police car, right? So you'd say dx on dt is, well, some of you have said 80, and have forgotten that actually he's getting closer to the intersection. So really it should be negative, right? So it'd be minus 80. And then you've got the other guy, and so we'll call this distance, say y, that's what most of you have called it. And you know his rate as well. So you've got dy on dt being equal to, now this rate is growing, so it's 60. Okay, and then you think to yourself, here's my setup, and now as usual I go to chain rule, right? So I would say what I'm after is d theta on dt, okay? So that's going to be equal to d theta on something times something on dt. And then you pause for a moment, because you look at what you've got here, and usually there's just one thing to choose from up here, and it's like an A or a V or an X or whatever, okay? And you could think, okay, well I've got dx on dt and I've got dy on dt. So which one do I choose? And then you might think, well, okay, I'll just slap an x in there. So you get dx, and then you've got dx. But then you realize you've got a problem, okay? dx on dt, that's fine. But d theta on dx, d theta on dx, that's saying there's some relationship between theta and x, which is true. There is a relationship between theta and x. But theta depends on more than just what x is, doesn't it? Theta, this angle, comprises of these two sides, right? And they're both changing. That's why this is the example I chased after. Because usually it's just like one guy, the radar tracking station who's stationary and the plane is flying past. Okay? So there's just one thing that's changing, that's why you put it in here. But there's two quantities changing. So if I've got my x's in here, where do the y's go? And clearly the question, our solution has to take the y's into account because they're changing. Okay? They affect the answer. So what do we do? Okay? What I'm going to suggest is you scrap all of this, okay? Because basically, this is what I mean by you're heading towards a brick wall. This setup is flawed already, okay? Because you've got this, which ignores y, which you can't do. You can't ignore y, right? So we need to rephrase this in a way which will take y into account, okay? So be patient with me. I'm going to get rid of all of this. And if you've got something similar to this, I'm going to suggest that you also get rid of it. Okay, so